Topic 4, roots of polynomials. This topic is all about finding the roots of a given polynomial. Another way to think about it is eventually we're going to solve polynomials to find out all of the roots or zeros that exist within the polynomial itself. And we're going to do this algebraically. We found them graphically, or we've at least found the real solutions where they cross the x-axis, but now we're going to find all solutions. In this, you're going to encounter, like I said, real solutions where they cross the x-axis, but you'll also encounter imaginary solutions that don't cross the x-axis as well. Now, to begin, I have to talk about 3 theorems that exist in Algebra 2 because they kind of set up the process of finding the real and imaginary solutions of a given polynomial. The 3 that exist, and this is objective 1 in this video, and I'm only going to talk about this objective within this video. The fundamental theorem of algebra, the remainder theorem, and the factor theorem. Alright, so we're going to learn a little bit about what each of these are. To begin, the fundamental theorem of algebra is a very straightforward theorem. If I'm given a polynomial function here or here, this theorem, the fundamental theorem of algebra, states that the highest power determines the number of roots that exist. And that is very important because when you go to solve one of these things, your first step should look to see what is the highest power, because that'll tell you how many solutions you're looking for when you solve this thing. So, in this case, this first example here, it is already in standard form. It goes from highest power to lowest power. The highest power is 4. So in that case, it is exactly that. I am going to look for 4 roots / solutions / zeros. I can't necessarily say that they're going to be 4 x-intercepts because I don't know if they're going to cross the x-axis. All I know is when I solve this thing, I will have 4 solutions, all right? And then take a moment to think over here, this example, the highest power is right here, so you should be able to predict that this one will have 5 roots or solutions or zeros, all right? And if you notice, one is even 4 and one is odd 5. That comes into play later when we talk about imaginary solutions, but I'm not going to mention that in this video yet. So that's the fundamental theorem of algebra. We are done with that one. Nice work. Now let's move on to the remainder theorem. The remainder theorem and the factor theorem kind of go hand in hand. We're going to talk about division in the next video. We're going to actually divide factors from polynomials. And once we do the division, the remainder theorem states that if the remainder after that process happens is 0, or in other words, there is no remainder, then the given x value, or the root or solution that we're trying to evaluate, is indeed a root or solution. Alright? So if the remainder is 0, then that value is a root or a 0 of that polynomial. Now remember that evaluate is just another word for divide out, or just divide. And that's what we're going to do. The factor theorem states that if there is no remainder, or the remainder is 0, after dividing any given function by k, or the polynomial x minus k itself, then this x minus k is a factor of the polynomial. Given polynomial. So let's look at an example really quick. This is what you're going to do in the next video, but I just want to kind of put these thought processes into play. If I'm presented with this problem, number 1, it gives me a big polynomial right here, 7n to the 4th plus 11n cubed minus 30n squared minus 2, and they're asking you to divide 7n minus 10 out of it, all right? If I do this process, this 5-step process, and at the end there is no remainder left over, then 7n minus 10 is a factor, and the solution form of that, or the root form of that, which I would set 7n minus 10 equal to 0 and solve for the variable, that is also a root. So if there is no remainder, then the factor in question is indeed a factor of the polynomial, and the root of that factor is indeed a root of the original polynomial as well. That is all that stating. So please keep that in mind as you're doing this process. So if I ask you the question, is it going to be a root of the polynomial, or is that factor indeed a factor of the polynomial? You should be able to answer yes or no based off of if there's a remainder or not. That's all that these three things are stating. So key point, if the remainder is 0, then it is a solution and it is indeed a factor as well. Thank you.